Today's lesson, we are going to take some data, some raw data, not a graph, but some raw data, and try to fit it to a sine curve. And today, every graph that, or every equation that you're going to make is going to need to be a sine equation, okay? So every equation today is going to need to be of this form right here. I'm not going to give you the option of calling it a cosine equation. You have to call it a sine equation, which means you're going to need to calculate this phi right here, or this number that gives you that horizontal shift, okay, that left-right shift. All right, so here's some raw data. If we were to graph this on a curve, which I probably should have done so you could have pictured it, it would definitely be a sine curve kind of thing. And that makes sense if you think about monthly temperatures. Clearly they're colder in the winter and then gradually get warmer and then obviously trail off again in the fall and the cycle continues. So we're going to take this data and we are going to fit it to a sine equation. So the first thing we want to do in that equation is find the amplitude. And that amplitude you can it says on your notes, is the largest value minus the smallest value divided by 2. And it's the largest y value. So the months, the time is going to be on the x-axis, and the temperature will be on the y-axis, just so you know. Okay, so I am looking for the largest and smallest y values, which you can see are 29.7 and 73.5. So coldest in January and warmest in July, that makes sense. To find the amplitude, you will take the high minus the low, divide your answer by 2, and you will get 21.9. Okay, then the midline of your curve, same numbers, only it's the high plus the low divided by 2. And when you do that, you will get 51.6. Your W is kind of determined by your period. To find your W, you will take 2 pi divided by your period. If you think about this, it gives you the temperatures by month. And so it goes from January, February, March, all that. The temperatures are by month. The pattern will repeat itself once a year, but because they gave you your data in months, then your period is 12 months. You don't want to call it 1 year. You don't want to call it 365 days. They gave you your data in months, so your period is 12 months. It'll be that same average temperature again. If it's this January, it'll happen again next January, which is obviously 1 year or 12 months. So your period, 2 pi in this case over 12 for the months, which obviously reduces to pi over 6. All right, none of that is going to be too difficult for you, I don't think. But this next part, calculating the phi, gets a little bit tricky, so try to pay close attention here. Okay? You determine that phi, or that horizontal phase shift, by plugging in the ordered pair for which y is the smallest. So you're going to look for your smallest y value. And we know from our data right here that our smallest y value is up here. Our y value is 29.7. January you're going to call month 1. And so you're going to make a little coordinate out of this that goes 1, comma, 29.7. And that's the coordinate you are going to use when you are calculating your phi. The y value that is the smallest. So month 1, temperature 29.7 in this case. What you're going to do is you're going to plug it into this famous equation that we have looked at over and over and over and over again this chapter. Okay, your amplitude you're going to get from above, we already plugged that number in. That would be 21.9. I'm telling you it has to be a sine curve. Your W you calculated as pi over 6. I'm going to leave my x blank here in a minute and I'll talk about that. My phi is what I'm trying to find. I'm trying to calculate that. My midline I calculated up above, and my B was 51.6. Okay, then what goes in here is your y value of your coordinate. So in that spot is my y value, which happens to be 29.7. So 29.7 here, and this obviously is your x, and your x value right here is 1. Okay, so I'm going to plug 1 in for x and 29.7 in for y. I plugged in my amplitude, my midline, my everything else, and I'm going to solve here. Okay. So, this is what I have. I am going to subtract 51.6, and I will get negative 21.9 equals 21.9 sine, and then right here, pi over 6 times 1, obviously is just pi over 6. minus phi. I will divide by 21.9, and I will get negative 1 equals sine at pi over 6 minus phi. Okay, now I have to tell you this. If you have done this correctly and you have plugged in the right coordinate, you should always, 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 every single time, come up with an equation that is negative 1 equals sine of some quantity. Okay, every single time it should say that. Negative 1 equals sine of some quantity. Okay, now here comes the tricky part. You're going to follow the same exact process every single time, but you need to know why you're doing what you're doing. Okay? Here's what I know. If you think about the unit circle, okay, and you know that sine is your y values on the unit circle. So what this equation is telling me is that sine at some spot on the unit circle is negative 1. So sine at some spot on the unit circle is negative 1. And if you think about the unit circle, your y value or your sine value is negative 1 right down here at 3 pi over 2. It is the only spot on the unit circle where your y value or your sine value is 3 pi over 2. Okay, so now I want you to think about this. Negative 1 equals sine of 3 pi over 2. Sine at 3 pi over 2 is negative 1. This is a true statement. So now the question becomes, what do I have to plug in for phi to make this be 3 pi over 2? That's the question. So pi over 6 minus what number is going to make that equal 3 pi over 2? Because 3 pi over 2 is where sine is negative 1. So the process you're going to follow every single time you get to this point is you're going to take what's in parentheses, which is pi over 6 minus phi, and you will set that equal to 3 pi over 2. And again, that's because that's the only spot on the unit circle where your sine or your y value is negative 1. Okay, and now you need to solve. So I will subtract pi over 6. And I get negative phi equals 3 pi over 2 minus pi over 6. And if you get common denominators and everything, you will get 4 pi over 3 there. So then positive phi is negative 4 pi over 3. Okay, so there's my phi. I got that. Now I need to go back and I just want to make my grand final equation with everything plugged in. So here we go. Y equals, my amplitude was 21.9, sine, my W was pi over 6, minus negative 4 pi over 3. So minus a negative 4 pi over 3 obviously is going to become positive, but I wanted you to see how we got that. And then plus my midline, which is 51.6. Okay? And that is the final answer to this problem, which took a little while, but we got it. Okay, and we're going to do a couple more just to make sure you're okay. This one has to do with average hours of sunlight, and it kind of assumes you know some things that are maybe not so obvious in this problem, so I wanted to go over it just to make sure we're all okay. But I hope you know that the summer solstice is the day of the year where there's the most hours of sunlight, and the winter solstice is the day of the year where there's the least hours of sunlight. Okay, so I think you can probably find your amplitude and your midline pretty easily. Obviously, this is the largest, and this is the smallest. And so to find amplitude, you will take the large minus the small, and divide it by 2. And you will get 3.108. And then for the midline, obviously, you'll take the large plus the small, and divide it by 2. And you will get 12.175. Okay. Then your period, summer solstice, again, is the longest day of the year. So because I'm giving you your units in days, your time in days, then your period will be 365 days. There's 365 days from one summer solstice to the next. So to find W, again, you'll do 2 pi over your period, which in this case, since you're given your time in days, your period will be 365 days. Okay, so that is your W. All right, here comes that tricky part, the phi. Okay, so we first of all need to find a coordinate. And again, to find the coordinate, you need to plug in the lowest y value. Well, we know that the least number of sunlight has, or days of sunlight, has 9.067 hours of sunlight. It's the shortest day of the year. The problem is it didn't give us an x value that goes with it. So this is what it assumes you know that you maybe don't. If you don't know, the winter solstice is December 21st. Obviously, there's 365 days in the year, and December 31st is the last day of the year. So if there's 365 days, December 31st is the last day of the year, then December 21st, when the summer solstice occurs, is the 355th day of the year. So that's a little bit tricky there. All right, so now, again, we're going to plug everything back into this equation. And we're going to plug this in for x, and we're going to plug this in for y. And obviously, we'll plug our amplitude in, and our w in, and our midline in, and then we'll need to resolve for phi. Okay, so here we go. We have 9.067 equals 3.108 sine of w, which is 2 pi over 365. My x that I'm going to plug in was 355 minus your phi plus your w, or plus your b, I mean, sorry. Okay, then obviously I'll subtract 12.175, and I'll get negative 3.108 equals positive 3.108 times sine at, now I'm going to simplify this, so I'm going to go 2 times 355 divided by 365, math enter, and then throw the pi back in there. And when I do that, that should reduce to 142 pi over 73. So now I'm here. Divide by 3.108, and I get negative 1 equals sine at 142 pi over 73 minus phi. Okay, and so here's that part you're going to do every single time. Again, when you think about your unit circle, the place where sine, or your y value, is negative 1 is down here at 3 pi over 2. So you need to figure out, what do I have to plug in for phi to make this quantity right here be 3 pi over 2? Because we know that sine at 3 pi over 2 is negative 1. So that's what you're going to do, and then you're going to solve. So I will subtract 142 pi over 73. Okay, and use your calculators, you guys. That's what you have them for. So I would take 3 halves minus 142 over 73, hit math enter, throw the pi back in there, and I should get negative phi equals negative 65 pi over 146. So positive phi equals positive 65 pi over 146. Okay, so there's my phi, and then when I plug in my whole equation, I will have this. And it will look like that. Okay, and one more. All right, this one's a little bit different style, but it's talking about the pH value of a water supply, and it oscillates. That means it goes up and down and up and down between 7.2 and 7.8. Okay, so on this one, it might be almost a little bit helpful to kind of think about a graph a little bit. It's going back and forth from 7.2 to 7.8. I don't know where it falls along the x-axis, but I know that the low point is 7.2, and I know that the high point is 7.8. I know that. Okay. So you can kind of figure that out. And somewhere along this circle, it's going back and forth, back and forth, back and forth like this between 7.2 and 7.8. We know that. Okay. So here we go. Obviously, the high point is 7.8 and the low point is 7.2. So my amplitude, 7.8 minus 7.2 divided by 2 will be 0.3. My midline, or my B, will be 7.8 plus 7.2 divided by 2, which is 7.5. My W is 2 pi over my period, and this is a little bit tricky in this case, so that's why I want to make sure I kind of draw the graph. What it says is it takes 2 days for it to go from 7.2 to 7.8. So it takes 2 days to go from here to here. So this is 2 days from there to there. Okay. And then it takes another 2 days to go from high to low again. So it takes another 2 days to go from here to here. And this much from one low point all the way back to the next low point is one full cycle. So many people think that the period is 2 days when the period is actually 4 days. Okay, so there's your W. And then we're going to go find our fancy phi. And again, to find your phi, you need to know the lowest value and when that occurs. So the lowest value is 7.2 on day 13. And again, time will always be on your x-axis. So day 13 is your time, and the y value of 7.2 is what you're going to have there. Okay? So here we go. I am going to go like this. I'm plugging everything into that equation. My y value is 7.2. My amplitude was 0.3. My w was pi over 2. That happened where my x value was 13 minus phi plus my midline, which was 7.5. Okay? So again, I'll subtract 7.5. And I get negative 0.3 equals positive 0.3. Sine pi over 2 times 13 will be 13 pi over 2. Divide by 0.3, negative 1, equals sine at 13 pi over 2 minus phi, like that. And again, shocker, we got negative 1. We should have. Okay. And once again, your process is to take this part right here and set that equal to 3 pi over 2 every single time, because that's where your y value or your sine value is negative 1 on the unit circle. Subtract 13 pi over 2, and I get negative phi equals, and again, take 3 halves minus 13 halves, you should get negative 10 halves, which is obviously negative 5 pi. So positive phi is positive 5 pi. All right, and then when I plug everything in, it will look like this. And that's what it should look like. So hopefully you'll be okay.